Okay, this is on areas of regular polygons and what they call composite figures. Okay, the one thing that you need to go back and look at is this term. And remember, when we talked about polygons, the polygons all have straight edges. There are no curves in there. But when they say it is a regular polygon, that means all of these sides are congruent. Okay? And we're going to look today specifically at areas of regular pentagons, regular hexagons, and regular octagons. And we're going to find the area of that. This is one that you would not have probably covered before. Another thing that you need in this is the definition of an apothem, okay, or apothem, depending on how they pronounce it. If you take a look at the pentagon and say the apothem is the perpendicular distance to one of the sides, all of these, and I've labeled one up here, here's another one, okay? It is the perpendicular distance. Okay. On the octagon, I've labeled one of them right here. Okay, it is that perpendicular distance. On the hexagon with 6 sides, that's the apothem. Okay. Okay, so if a regular polygon has an area, okay, of a square units and a perimeter distance around and the apothem, okay, then the A equals. Okay, this is the general formula for a regular polygon. Okay, it is 1/2 the perimeter times the apothem. So this is the general formula for area of a regular polygon. Okay, the uppercase A stands for area. The P stands for perimeter. That's the distance around the outside. And the lowercase a is the apothem. The author also goes back and reviews the area of a circle. Area of a circle is pi r squared. Okay? So, we are going to find, I'm going to go through each example, and the examples are basically the same as far as for every regular pentagon, for every regular hexagon. So, the first one we're going to do is a pentagon. It's got 5 sides. They are all congruent. Okay, and the first thing you have to figure is you got to figure this. You got to figure this apothem. Okay, and then you also have to figure the side. You need to know this side and go all the way around for the perimeter. To figure that, I've given you an angle here, and you have to know how they figure that angle. What I do is I always take on a pentagon, I say draw a circle in the middle. All the way around is how many degrees? For a circle, how many degrees? 360. So if I take 360 degrees and divide it into, there are 5 sections. Okay, so if I divide it by 5, I end up with 72 degrees. So each one of these is 72 degrees. But if I drop a perpendicular down, okay, then that bisects that angle. So each angle inside here is, this angle is half of 72 degrees. So it is 36. For every regular pentagon, that angle is going to be 36 degrees. Every regular pentagon. Okay? But that's the easiest way to find it. Think about your circle, divide it by the number of sides or number of triangles, okay, and then drop your perpendicular and bisect it. Okay, so we've got our angle. Okay, now we've got to figure A. This comes back to your tree. In terms of this 36 degrees, and on this one the author did give us, I guess I should say the given was that value was 3 units. Okay, so I know the length of each one of these is 3. The hypotenuse, basically, in this right triangle, the hypotenuse is 3. Okay, so if I want to figure A, in terms of this right triangle, okay, what side is A compared to that 36 degrees? It's the adjacent side. So I have adjacent, and I have the hypotenuse. What trig function? You have to go, yeah, cosine. You got to go back to chapter 8. So it's cosine of 36 degrees. And I would still write out the definition. The more you write that out, the better. Cosine of 36 is the adjacent over the hypotenuse. Okay, and cosine of 36, the adjacent side is A. The hypotenuse, we can sub in, the hypotenuse is 3. Okay, now on your calculators, okay, first you have to double check your mode. Make sure you're in degree mode, and I would go 4 decimal places. Okay, and then let's go cosine of 36, and I get 0.8090 equals A divided by 3. You're dividing A by 3, so do the inverse, multiply by 3. Or you can also do this. You could cross multiply. Okay, so you'd have, take what's on your calculator times 3, and I get 2.4 for A. Now, I'm going to store that value. This is probably the first time we've used the memory keys on the calculator. Okay, so on your calculator, right above the on key, everybody look up here for a minute. Right above the on key, on a key by itself, you find this, STO on a key by itself. That's your store, your memory key. Okay, so hit that, store it. It's gonna put this on your calculator with an arrow. Okay, that arrow is always using the storage. You have several memory buttons. Any of the green letters, look above the math key, there's an alpha A, a green A. Above the apps key, there's a B, a C. You can store things in all those. Okay, so since this is an apothem, I'm going to store it as A. So you need to use the green alpha key and the A above the math key. Okay, so it's going to look like this. Okay, and press enter. Okay, now that's in the memory. You can turn your calculator off. You can come back Monday and that value's still in there. You don't ever have to clear the memory. You just store over it with new things. Okay, so that's in the memory. We know what the apothem is. Okay, now we need to figure the x. In terms of that angle, what side is the x? Opposite, adjacent, hypotenuse. Opposite. And we still know the 3. You don't want to use this value we solved for. You always want to use the given. So in terms of that 36, it's opposite over hypotenuse. So that is sine. Sine of 36 is the opposite side over the hypotenuse. So opposite sine of 36, opposite is x. The hypotenuse is 3. Okay, now on your calculator, do sine of 36 and press enter. I get 0.5878 equals x divided by 3. You're dividing by 3 and you want to get x by itself, so do the inverse, multiply by 3, or you can write it over 1 and cross multiply. You're still multiplying by 3, so take what's on your calculator times 3, and I get 1.7, 1.8 if I round it. Now I'm rounding it on the paper. I am not going to round it on the calculator. Okay? That 1.8 is this x. Okay? Now I need this whole side. So to get the whole side, multiply it by 2. So multiply 1.8 times 2 to get the side. So on your calculator, take the 1.7634 times 2. I get 3.52. Okay, 6, 7. Okay. Now, to get the perimeter, I have 5 sides. I now know one of them. So take what's on your calculator times 5. Okay, and I get the perimeter is about 17.6 something. Okay. Now, I do not want to have to type that in again. I want to store it. Okay. So hit the store key. Okay, and it's the perimeter, so store it as alpha P. So use your green alpha key, and P is above the 8. Okay, so now that's in the memory. Okay, so now I need to go back to the original formula. Go back to this formula, write it down. Okay, so I have the 1/2, I'm going to go ahead and change that to 0.5 times P times A. I do not have to write those down, they're in the memory. Okay, so take on your calculator 0.5 times alpha P times alpha A. Okay, and I get 21.4, right? If I round it, it says nearest tenth, so we're good. 21.4. Okay? So I think this is a valuable part on the calculator, is to store values. Okay, and it saves you writing down all those decimals. Okay? Everybody good on that one? Okay, go to the back. Any regular pentagon, it's going to be 36-degree angle. Okay, on number 3 on the back page. This one is a regular hexagon. Okay, you might go ahead and mark that's regular, so all those sides are congruent. For a regular hexagon, okay, if I did this, if I said all the way around is 360 and divide by 6, 360 divided by 6, it'd be 64. So each one of those triangles, this is going to be a 60, a 60, a 60. So if I give you this is 7, every side in there is 7. So that means I've already got that. Okay? Make sense? All of those would be the same. Okay, and then if you drop the perpendicular, you bisect that 60 and make that a 30. So now you have a 30, 60, 90 right triangle. So what we really have to figure is that apothem. Okay? If I have a 30, 60, 90, okay, and I give you this is 7. First, how do I get to this side? Divide by 2, so that would be the 7/2 or 3.5. Okay, and if I doubled it, this would be the 7/2, and this would be the 7/2, and if I double it, I get to the 7. And then to get to this one, yep, so 7 radical 3 all over 2. Okay, so that is the apothem. Okay, that's the A value. This would be the 7 radical 3 all over 2. Okay? Okay, so now we know the apothem. What we do need to get is the perimeter. The perimeter, there are 6 sides in a hexagon, so 6 times 7. Perimeter we know is 42. Okay, so now write down the formula. The area equals 1/2 the perimeter times the apothem. And the order doesn't matter. You can go apothem times perimeter. So it would be 0.5. Perimeter is 42. The apothem is 7 radical 3. And it's all over 2. Okay? And then multiply those out. Okay? You really don't have to store anything on that. You can go 0.5 times 42. And that's 21. And then you can take that times, I would multiply by the top part, times 7 radical 3. You get 254.6, and then divide that all by 2. Okay. Okay, and nearest tenth would be 127.3. And that's in square units. It would be square units. Okay, so every hexagon, regular hexagon, is going to be a 30, 60, 90 right triangle. They're not quite as much work. Okay? Okay, go to the bottom one, the octagon. Okay? For the octagon, and these are all, you get split it up into 8 triangles. It's got 8 sides, and each one of these is congruent. And what you really have to figure out is that angle. Okay, so if you take all the way around in the circle, it's 360. and divide it by 8, you'd end up with 45 degrees. And then if you drop each one of these, it'd be 45. And if you drop the perpendicular, okay, then you're bisecting that angle and you get 22.5. So this little angle inside here is 22.5 degrees. Okay. Okay, on this one, look and see. I don't think I marked it. This is 11. I don't think that showed up on your paper. The hypotenuse there is 11. Okay? And we need to figure the apothem, and we need to figure this x value. Let's figure the apothem first. In terms of that angle, the apothem is the adjacent, so it would be cosine of 22.5 degrees equals the adjacent over the hypotenuse. So cosine of 22.5, the adjacent side would be A, the hypotenuse would be 11. Okay? So on your calculator, figure cosine of 22.5. Okay, and we got 0.9239 equals A divided by 11. That's an A. Okay, so do the inverse, multiply by 11. And I get 10.2 if you round it for the paper. But I don't want to use 10.2 on the calculator. I want to use the whole value. So store it. So use your store key and store it as alpha A for the apothem. Okay? Then let's figure x. In terms of that angle, x is the opposite, and we know the hypotenuse is 11. So sine of 22.5 is opposite over hypotenuse. Sine of 22.5, the opposite would be x, the hypotenuse would be 11. So figure sine of 22.5, I get 0.3827 equals x over 11. Oh, sorry, wrote the wrong thing. X over 11, multiplied by 11 on your calculator. Okay, and I get x is about 4.2. Okay, now that's just this part. Okay, we need to double it, so take that times 2. Okay, so I get this is about 8.4. Okay, and then you've got 8 sides because it's an octagon. So now we need to take the 8.4 times 8. Okay, so the perimeter then is about 67.35. Okay, store that as the P. So store it as alpha P. Okay. Okay, and then you're back to the formula area equals 1/2 the perimeter times the apothem. So we need 0.5 times P times A. Okay, so 0.5 times, bring back the alpha P, times alpha A. Okay, and I get 342. 342, and nearest tenth would be 0.2. Good with that? Okay, so for every regular octagon, this angle is always going to be 22.5. Okay? And they can give you any of these. They might give you the apothem and have you figure well, actually, if they gave you the apothem, they might have you figure the perimeter. For any octagon, this angle is always going to be 30. It's be a 30, 60, 90. For any pentagon, this will always be 36 degrees. Okay, as long as they're regular. Okay? Okay, that should give you enough. Any questions? Okay. Should give you enough to go on. Okay?